Hello again, everybody. We're back again. Video 2 in this concepts of oxidation and reduction videos. Okay, this one we're looking at oxidation numbers. Remembering from the first video, I did indicate that we would look at oxidation numbers in the second video. So that's what we're doing now. So remembering that not all redox reactions will involve a transfer of electrons. In this instance here, I've got a transfer of oxygen. So I've got two reactions here. There's the oxidation of carbon and the oxidation of hydrogen here. Carbon gains the oxygen. Hydrogen gains the oxygen. So they've both been oxidized. The electrons in this instance are shared, not transferred. For a small tip is that the oxidation numbers are closely linked to valency. That gives you an idea of how to work them out. Okay, the oxidation number is the imaginary charge an atom would have if it existed as an ion in a compound. So a definition, going back to what we had in the previous video, was that a oxidation is an increase in the oxidation number of an atom, and reduction is a decrease in the oxidation number of an atom. Okay, oxidation numbers show the total number of electrons which have been removed in a reduction or added in an oxidation to an element to get to its present state. A change in the oxidation state of a substance indicates that the reaction is a redox reaction. There are, of course, rules. They're always written as a positive or negative whole number, and they indicate a gain or loss of electrons. And they're written using a positive or negative as a superscript above the symbol. For example, with calcium, oxidation number is 2 plus. For oxygen, the oxidation number is 2 minus. Okay. For chlorine, a pure element, the oxidation number is 0. For silver, a pure element, the oxidation number is again 0. Okay. When we're looking at elements or oxidation numbers, there's some rules that we need to pay attention to. Oxidation number for any element is 0. For a monatomic ion, for example, Cl minus, my oxidation number is going to be the charge, and this instance is going to be -1. For hydrogen, it'll be +1, except in a metal hydride, for example, sodium hydride. In this instance, my oxidation number for hydrogen is going to be -1. In all instances, oxygen in a molecule will be -2, except for when it's in peroxide, which looks like this, when my oxidation number is going to be -1. The total of oxidation numbers in a covalent compound is going to be 0. And the total for a polyatomic ion is going to be whatever charge that ion happens to be. For example, if I go for MnO4 minus, the total oxidation numbers will, the oxidation numbers will total a -1. Okay, so let's have a look at the next part. Atoms of a chemical element can have an oxidation number that is a variable, so there's always an exception to every rule. And this depends on the atom's ability to gain or lose different numbers of electrons within a chemical reaction. So let's have a look at some examples. So I've got some oxidation number of nitrogen happening here. If we have a look at this first one, I've got nitrous oxide. Remembering, oxygen in any compound is going to be -2. My overall charge for my compound here is 0. So therefore, if this is going to be -2, for my overall charge to be 0, this then has to be +2. And so nitrogen is +2, and it's written like this over here. Let's have a look at the next one, is ammonia. NH3. In any compound, hydrogen has a charge of +1. I have got 3 hydrogens, so that's going to be a +3 charge there, which therefore means this has to be, mathematically we can work it out, 3 lots of +1 plus my nitrogen gives me my overall charge of 0. So therefore, my nitrogen has to be -3, and it's written like this, +3 over the hydrogen, -3 over the nitrogen. Okay, let's have some examples with some equations. Looking at the first one, I've got lead. solution reacting with magnesium solid, forming lead solid and magnesium in solution. Okay, having a look at the leads first. On the left-hand side, I've got an ion, so therefore my oxidation number is going to be +2. It equals the charge on the ion. And on the right-hand side, looking at the ion, it's an element, so my oxidation number is going to be 0. According to our rules, a decrease in oxidation is a reduction, so therefore the lead is reduced. Let's have a look at the magnesium. Magnesium as an atom, as an element, it's going to have an oxidation number of 0. And as an ion, it has oxidation number of whatever the charge happens to be. And so this instance, it's going to be +2. Again, following our rules, an increase in oxidation number is an oxidation reaction. Therefore, we can say the magnesium has been oxidized. Okay, let's have a look at the second one. There's 3 species to pay attention to here, so it's going to be slightly more complicated. But let's begin with our pure elements. Pure elements, both F and 0, we can have oxidation number of 0 on the F and 0 on the oxygen here. Looking at the water, remembering within a compound, oxygen will always be -2 and hydrogen will always be 1. Balancing the molecule, I've got 2 lots of +1, so that should fit nicely in there. Hydrogen fluoride. Hydrogen is -1. Sorry, is +1, and that means the fluorine is -1. Which species is being oxidized, reduced, or staying the same? So I want you to pause the video here for the minute, and I want you to write down which species is being reduced, which species is being oxidized, and which is staying the same. Pause it, come back to me and have a look. Hydrogen, +1, +1, no change. So there's no reduction, so we'll put the hydrogen in here. Oxygen has gone from -2 to 0, so therefore it has been oxidized. And the fluorine has gone from 0 to -1, and it has been reduced, so that fits into that one. Okay, and therefore it is a redox reaction. Let's have a look at another example. I've got some polyatomic ions. So let's see if we can find out what the oxidation number of the chromium is in this the dichromate compound. Okay, oxygen is -2, as always, and there are 4 of them. Means this has to be -8. For my thing to be balanced, chromium plus -8 will equal -2, because that is the charge on my ion. Therefore, chromium has to have a oxidation number of +6 in this instance. Okay, let's have a look at the next one. What is the oxidation number of chromium in this chromate molecule? Sorry, that was not dichromate, this is dichromate, my error. Okay, again, oxygen, I'm going to write it down here, Cr2, O7, 2 minus. -2 times 7 gives me an overall charge here of -14. So, chromium, take 14 with a -14 is going to equal overall charge of a molecule is -2. Forgetting here that we had 2 chromiums. So 2 chromiums take 14 gives us -2. In this instance, the chromium molecule has, again, an oxidation number of positive 6. Bit of mathematics there for us. Let's move on to the last slide for here. I've got a complex equation that we're going to be looking at. Got magnesium oxide plus hydrogen ions plus ions gives us magnesium, water, and iron. Okay, so let's have a look at the oxidation numbers. Remembering, oxidation number for oxygen will always be -2 in a molecule. I've got 4 of those, so that's going to be -8. The charge on my molecule is -1, so that means my magnesium is going to have my manganese is going to have a oxidation number of +7. Hydrogen ions will always be -1. My iron, I have a charge of my overall ion here is +2, which means my oxidation number for my iron is going to be +2. Let's have a look at the right-hand side. For magnesium, my manganese again, overall charge of my iron is +2, so over here, my manganese is going to have a charge of oxidation number of +2. Looking at the water, -2 for my oxygen and +2 for my hydrogens. And at my ions on the right-hand side, I've got an overall charge of my molecule of +3, so that means my iron oxidation number is going to have to be +3. Let's have a look at the manganese. Has it actually changed? So manganese has gone from +7 down to +2. It's a reduction in an oxidation number, so this material has been reduced. Okay, let's have a look at the other one. In this instance, we're paying attention to is the iron. Having a look at these two. Okay, iron started off being +2 on the left-hand side, and when we finished our reaction, it was +3. I've got an increase in my oxidation number, so therefore we've got an oxidation reaction happening here. And that concludes this particular video. I am going to ask you to view the main PowerPoint, all the other videos that are linked on OneNote. Have a look at the notes in the textbook and various worksheets that I've put up on the OneNote as well. Thank you. See you in the next one.